Ah, yes. Does it work now? 1, 2. Horen jullie mij? Of hoort mij zo ook? Komt dat door? Ja? Oké. Nee, het is... Ja, ze zit daar nog aan de knoppen te draaien, maar het schijnt oké te zijn. Oké, goedenamiddag allemaal. Ik ben Stefaan Dondijnen. Ik werk voor de VUB. En dus we hebben dit jaar het genoegen gehad van hier met deze hele grote groep van studenten een geïntegreerd practicum te mogen organiseren. En dus we gaan vandaag de finale presentaties hebben van de studenten, dus jullie zijn allen van harte welkom. Als het oké is, zal ik vanaf nu in het Engels overschakelen. I will switch to English. So I'm introducing the idea of the integrated project, and that we are very grateful that we have had this opportunity to do the work here. And I'm very proud that you will present it here. Just to give some background, we have students from 2 master programs, one organized by University of Ghent in collaboration with VUB, and that's on a master in sustainable land management, where they have actually a very strong component in hydrology and groundwater hydrology. And we have also another master program organized by KU Leuven, again in partnership with VUB, on water resource engineering. In the sustainable land management, so these are the second-year master students. They have all this as a compulsory course to participate in such an integrated project. And so this year we're fortunate to organize it here. The students from KU Leuven VUB, they actually had the option between 3 different integrated projects. One was in Ecuador, in Cuenca. One was in Nice, in France, and one was in Boechout. So you see the level of Boechout is on the same level as Cuenca and Nice. Eh? Sorry for the Equatorians. Oh. Okay, about that, so they will present. I think for them it's well, personally myself, I've worked many years abroad, particularly in African countries, and I always felt very privileged whenever I could go to any office of a local institution, government institutions. And so I think it's great for all these students to have this opportunity to have this in return here. So I've more or less generically introduced them all to you. I think it would be nice if all the stakeholders here at least can briefly say who they are and who they are representing. And I would like to start, of course, with the representative, the elder woman from the commune. Is that a good start?
Very good. Very good. I am Chris Wagers, but I don't know what I do, how they call it in English. Counselor. I'm the counselor for environment over here. Okay, and I started up the Molenbeekbron from the beginning, and it's very close to my heart.
Hello, I'm Mark Thijs. I'm a member of the GECRO, in Dutch Gemeentelijke Commissie voor Ruimtelijke Ordening. And that's why I'm here. I'm also very interested because I'm very interested, and my house is just a side of what we are talking about.
My name is Philippe van Parijs. I'm an interested habitant from Boechout, also a member of the GECRO.
I'm Robert Vermetten. I'm also a member of the GECRO, and I think ecology and water management is crucial for us, so I'm interested to hear what you found out.
Well, I will then bring it to the back.
Good afternoon. My name is Nick Schrijvers. I'm the chair of the local department of Natuurpunt, which includes this community and also the community of Lint and Mortsel that are close by to here. And of course, the Molenbeek Valley is a very important part and a very important nature-based part of our unit of Natuurpunt. Thank you.
I'm Anja Wijfels. You already know me. I've been collaborating with you on behalf of the Nature Conservation Organization Natuurpunt and the local management team.
Frank Adriaansen, management team, Molenbeek Valley.
I'm Tine Verhees from the province of Antwerp.
My name is Chiara Bruckner. I work as a hydrologist at the Vlaamse Landmaatschappij, Flemish Land Government.
My name is Koen de Smet. I'm also a member of the management committee of the Molenbeek.
Hi, my name is Carol. I work at Regionaal Landschap Rivierenland as a Blue Deal worker. And I'm excited to know which are the things you're proposing for the Molenbeek Valley.
Yeah, hi, Tim Vives, Commune Boechout, Head of Environment.
Okay, so before I give the word to the students, what we actually did, as you all know, as stakeholders, the commune of Boechout together with Natuurpunt made a whole project proposal and submitted that for funding from the Vlaamse Milieumaatschappij. And I very unethically gave the whole project document to the students and asked them, now you guys, you are a consultancy company, please calculate, evaluate what is going to be the repercussions of this plan. I did it with the agreement, and so it's not so unethical. So now they will present, well, one of the specific questions we had was this project proposal is of course to take into account the climate which is changing. Can we actually see that the climate has been changing over the last 40 years or so? Does this have an effect on the groundwater level? So this is looking back to the past. The other thing we ask them is, these measures which are proposed, what will be the impact, the effect of it? So they will look at the surface hydrology, they will also look at the impact of the urban infrastructure, and they will also look at the aspects of the groundwater level. So, but I think I've talked already too much. I give now the floor to the students.
Okay, so hello everyone. Does everybody hear me? Okay, so before we begin, I think it's best that everybody who's going to talk sits a bit more this side, that the transitioning between the different parts will be fast. Yeah, you can stand there or here. There's an extra chair there. So yeah, how we structured the presentation, we're, like Stefan said, multiple student groups, and each group did their own section of the PowerPoint and will, of course, present their own results that they worked so hard for. So yeah, here are all the speakers. Okay, so then we're ready to begin. Oh yeah. Oh, that's good. Thank you. Okay, so most of the introduction I will not repeat. Stefan did it very good, but we are the UPR students and the Stulama students, and today we're very glad to show you what we found here in the source area of the Boechout, which is a very nice nature area close by here, and we gladly worked on there, of course. So first on background, of course, I assume you all know we're here in Boechout. Okay, so this area here is a source area of the Boechout, and more specifically in Boechout you have the whole catchment of the Boechout, and multiple nature-based solutions were proposed to improve this area. As you can see here, so there were new weirs, new ponds, a new forest and some reed beds that are planned to be installed. And the whole goal of these measures is to increase the biodiversity, to reserve it as well, to increase the percolation of water to the soil, to also reduce floods. Of course, all with an educational and recreational linkage, which is important for the commune, of course. And like Stefan said, we acted as a consultancy company, not paid. No, this is a joke. With 4 main questions. So first, what is the effect of climate change on the hydrology of this structure, so rain and also the groundwater levels? Then, what is the effect of these nature-based solutions on the surface water hydrology and also the water quality? Very important. Then there's also what is the effect of the urban water infrastructure on the hydrology of this catchment? And finally, what is the effect of what is the hydrostratigraphical structure of this region? So those are the 4 questions we hope to answer by the end of this presentation. Okay, so now we'll talk about the climate.
Thank you. Yeah. Well, as the weather is a crucial factor in the water management, in the water balance of the study area, it is obvious that climate change might influence the groundwater level, the average groundwater level in the area. In order to assess that, it's this way, we assessed the statistical relation between different climate parameters and the average groundwater level. And 3 of these parameters proved to be statistically significant. Those are the precipitation. For each millimeter increase in yearly precipitation, we observed a 1 millimeter increase in average groundwater level. A second one is the ET0, the reference evapotranspiration. And we observed that a 1 millimeter increase in daily reference evapotranspiration results in a 53 centimeter drop in the average groundwater level. And finally, the solar radiation, an increase of 1 megajoules per square meter per day. Increase in solar radiation results in a 21 centimeter drop in average groundwater level. Those are the only factors that proved statistically significant. All others were not significant.
Yeah, so now we'll talk about, you hear me? Yep. About the effects of the measures on the surface water quality and hydrology. So first I will do the section about the water quality, and then Leen will take over to do the hydrology part. So for the water quality part, we mainly focused on the reed beds. So the plan is we install reed beds, and they will remove nutrients like nitrogen and phosphorus, and that will, in theory, increase the quality of the water. Is that true? Well, we found out. So to find out, we of course went to the field, because you can't improve the water quality if you don't know the quality to begin with. So we measured the pH, the conductivity, the organic carbon, nitrogen, phosphorus, and all kinds of trace elements. So we took multiple samples at multiple locations. Then we did a literature study. So we took to literature just to have an idea, okay, how much can a reed bed remove nitrogen and phosphorus? How effective will it be? Just to have an estimate. And based on how good those data points were, we made several scenarios. For example, there was a scenario which used the exact data with the exact same plant types as will be used here, which is very nice, it's very relevant, so that will be our best estimate. And finally, we also used a chemical equilibrium model just to simulate the water. So that's to check a bit, okay, what we measured, is it a bit the same as what is modeled? And also to see what is the solubility of all those elements we measured. So here are the points we sampled. We sampled those points because between A, B, C, and D, the reed beds are planned to be installed. So, of course, now we have an idea what is the nutrient levels and the pollution in that area. Okay, so the results. Generally, the nitrogen levels were below the Flemish norm for good water quality, which is good. The phosphorus levels, however, at every location were way above the Flemish norm, which is not good. So for that, to reduce that pollution, we'll need a reed bed. That's the idea. And how much reedbed will need? Well, our best estimate is between 0.5 and 1.9 hectares. That's a long range. However, at the moment, only 0.13 hectares is planned, so we are almost sure that the planned amount of reedbed is not enough to reduce the phosphorus to a good water quality. So with the current plans of 0.13 hectares, the outflowing concentration will be between 0.21 and 0.25 milligrams per liter, which is less, so it works, but it's still above the Flemish norm of 0.14. And like I said, we also tested from some trace metals, and generally we found that there's a lot of cobalt, zinc and cadmium actually in these waters, with cobalt and zinc being more than the Flemish norm for good water quality at all locations, and cadmium only at point C. Now, is this a problem? Because of course that's the most important question here. Well, yes, we think, and we can prove it, the zinc levels are quite high. They are above the chronic effect level. So we expect that the zinc levels are high enough that they will pose a long-term effect on aquatic life, more specifically fish. So yeah, that's not great. And we think that this comes from an historic industry not far from the station, which was Werkhuizen Boechout, which worked with metals and has been a known pollution hotspot for zinc. It has been sanated, but apparently maybe some leakage went to the groundwater and came up in the source area. So that's our theory at the moment. Okay, so now we will go about the hydrology.
So in our case, actually in order to assess the effect of these interventions on recharge and discharge of the area, we use what's known as wet-spas model. Wet-spas model is a water-based model at which it's quasi-steady state model, physical distributed. In fact, we assessed the impact of the forest ponds and reed beds. The simulation was run for around 18 years, from 2003 to 2021, with and without interventions, and also for both the catchment and the project subcatchment area. Now, it's important to mention that the impact of years is rough estimates, so we cannot consider it as accurate estimations, but we can say that they are at the same order of magnitude. Now here, as we can see, that the recharge area in winter is high, in summer it reduces as expected. When we compare the recharge before and after the intervention, we saw that the overall recharge reduces. This is mainly because of the forest present. The forest, we make an assumption that the forest is deciduous forests. These forests actually have higher transpiration rate, higher water consumption, which can lead to lower recharge levels, as being said. Now, for the discharge, actually it's important to mention that the base flow is important in the discharge in the groundwater of our area. The discharge is high in winter, it reduces in spring, then it increases back in summer. This is mainly due to the fact that in spring the temperature starts to rise. This causes actually the plants to start growing, especially at critical planting growth stages. More water consumption is present. However, in summer, there are localized storms that are present in the area, which can cause actually the discharge to be increased. Concerning the interventions, as being seen in this graph, we have a positive but very modest influence of the interventions on the catchment discharge. As being seen, especially in 2016, 2017, it's more apparent. We can see that in dry period, which is considered a very dry year. In dry period, the discharge has a positive impact, which actually here reflects the difference between the intervention, with intervention and without intervention. However, in winter, we can see that it diminishes, or it keeps the water level at lower levels, so, which is mainly our purpose for the interventions. Now, for the subcatchment simulation, when we run the simulation for the subcatchment, we suggest that we will have a much lower or considerable decrease of the stream discharge. It's logical because the subcatchment actually is smaller in area than the catchment, at which the intervention can have a considerable effect when compared to the catchment area. However, it's important to mention that the new forest that is present, it reduces the runoff but consumes more of the available water. Here it's important to say that it's better to limit the density of the forest at which we can increase the biodiversity recreation, maintaining the recreational features, but at the same time limiting the water consumption in the area. Also, it's important to mention that there was a mismatch between the discharge proportions between the subcatchment to catchment, between the simulations and the measurement of the field measurements. This is mainly can be attributed to the fact that there are some inflow or additional inflow to the area that were not accounted in the simulation. Finally, concerning the placement of the weirs, we have 2 weirs, weir 1, weir 2. Weir 1 actually, it's present on block ditch, so it will not have an effect. There was no effect in our case for weir 1. For weir 2, actually, we made a simple calculation to just show the effect of the weir. As we said earlier, there are rough approximations. We can take them as order of magnitude, not as accurate results. As a result, the groundwater level difference between spring and winter was taken into consideration, at which it was found to be 17 centimeters, which is equivalent to a certain, as we said, to a certain calculation, taking the field capacity, the saturation. We found it to be equivalent to 31 millimeter when winter level is maintained. So weir 2 has a significant effect to the subcatchment, but when we put it to a larger area or to the catchment area, its effect actually will be reduced, which will be limited.
Thank you. Next, we want to talk about how the urban infrastructure affects the hydrology of the catchment. So. So here, what we would do is that we will identify the impervious areas, because these areas are the areas that affect the flooding rates, and the runoff, and also the infiltration. So we will identify these urbanized areas in the catchment. First, we want to consider the land use. The land use also has effect on the runoff and the infiltration. And from the land use map that we had, the land use areas, it was categorized into 19 distinct land uses. So we went on further to reclassify it into 3 distinct areas, which we classified it into the impervious areas, the tree cover, and the others. And the others is made up of, for example, the cropland and the hay fields. So we went ahead, we delineated the subcatchments into 13 subcatchments. Here we identified the streams, and then also we went ahead to select a suitable outlet for the catchment. And then based on the threshold given to the stream networks, we subdivided the catchment into 13 subcatchments for the work. This represents the parameters that we had, and from the parameters we can see that the basin area and then the basin slope, the area had the highest from basin 13, that was 1.07, and then the least was basin 8, that had 0.03, and then we have also the basin slope, the highest was basin 11, that was 0.04, and then the least was also basin 8. And then we have other parameters that helped us to identify some hydraulic characteristics, such as the lag time. And from the results we had, basin 7 illustrated, gave the highest impervious areas, which had 72.7%, followed by basin 2 and basin 6, which was 64% and then 36% respectively, as illustrated here. So here we can see that basin 7 also had the highest runoff volume, followed by basin 2 and then basin 4. We were actually expecting basin 6 to have the next, but then basin 4, and this shows us that runoff volume can also, other factors can also impact runoff volume, which is, for instance, the land use cover, the area of the sub-basin. And then from here, the light blue it represents the runoff, and then the deep blue represents the precipitation. And normally there's a red, there should be a red, which would represent the precipitation loss or the infiltration. And then we can see from sub-basin 7 that it's very minimal, followed by sub-basin 2, which shows that there is very minimal infiltration in basin 7, basin 2, and then basin 4, as illustrated here. And in summary, we have the total volume here, and then we have the peak discharge, which also shows the same, like sub-basin 7 having the highest volume of runoff here.
Okay. So we also had the task to come up with the hydro stratification of the catchment area. Okay. All right. So for one of the questions, we had the task to analyze or to address if there are artesian condition and also the prospect of infiltration to the groundwater table. So to actually do this, okay. So to actually address the first question, we reviewed data on the subsoil database of Flanders, and from the review we had, we could get the geology and the subsoil exploration reports, which could help us to see if there are artesian conditions in the area. And what are artesian conditions? These artesian conditions simply means condition where water can rise to the surface like naturally with pressure. For the second question, we had to talk about we had to analyze what are the prospects of infiltration to the groundwater table. And we use scientific methods to know how much water can seep into the ground. So here we see a longitudinal profile with different colors, like many different colors. So now, from this, we can see, from an analysis, we saw that there are different aquifers and aquitate. So we start with the boom aquitate. This boom aquitate is like the base, and it acts as a barrier which prevents water from going into the ground. Above this boom aquitate, we have the Cambrian aquifer. That is what we see in red and in green. And we had the Quaternary aquifer. That is what we see in yellow. So these aquifers, they join to form what we will call an unconfined aquifer. This unconfined aquifer simply means it has no barrier that could prevent water from rising up with under drilling with pressure. So we can say here that there is no artesian condition happening in this catchment area, like under natural conditions. There is no artesian condition here. But however, we see clay lanes in this area. And for the clay lanes, you see it in the clay patches, you see it in green. And these clay patches can affect the local water variation in this area. Like it can temporarily lead to high level of water, and as well as it can affect the seepage of water into the ground. So how do we go about identifying these clay patches? Like how do we identify it? So we reviewed data from the drilling and the lab tests in the study area. And from the data we reviewed, we could see that out of the 25 points, 5 out of these 25 areas actually are they were described as clay, and the remaining 3 are sand. The remaining 3 were described as sand, and that is from what you see on the map. And actually, if we have to draw a conclusion from this to say if there is an artesian condition, we would say there is not artesian condition in this area, in the catchment area, happening naturally. But however, we also experience that during the winter, there is like flooding in this area. So we could attribute the flooding due to the rise, the groundwater level is really shallow. So since the groundwater level is shallow, it cuts across and to the surface. And you can see that the water rises up in this area. This is basically due to the shallow groundwater table, not because of that there's an artesian condition happening in this area. And also, the bubbles you see in the area, because in the field we could find like bubbles in this area, we could say it's due to the gases that comes out from the ground and not actually artesian condition happening there. But if we want to go further to really pinpoint the areas where we can attribute it, like to really know if the clay lens in this area actually causes artesian condition, then we'll have to employ the geophysical methods, and which is what my next colleague will be explaining. After him, actually.
Okay, so that was for the artesian conditions. The other main question we have investigated is the prospect of infiltration to the groundwater table. First, measurements indicate a shallow water table in that area that fluctuates throughout the year between 0.5 and 2 meters depth. Then, if we look at the soil map of the whole Boechout catchment, we can identify 3 different soil types, so loam, silt loam, and sandy loam. But for this infiltration question, we focused on the upper part of the catchment, where the nature-based solutions were planned. If we zoom in on this zone, we observed that most soils are L, meaning silty loam soils. So these silt loam soils are in orange and brown on the map. And only the east part of the catchment in green contains more clay. These are not silt loam, but only loam soils. Now, to answer the question, we started to estimate the saturated hydraulic conductivity of the topsoil, which is the main factor influencing groundwater recharge in case of a shallow water table. And because the soil texture data was available, we've used it as an input, and we used a Peter transfer function to estimate KSAT. And the obtained conductivities are here. It's around 40 centimeters a day. That's low, so the infiltration there will not be high, but it's realistic values compared to other places in Flanders with this soil type. But other factors also influence groundwater recharge. Soil moisture, for example. The moister the soil, the more percolation will have to the groundwater table, and that results in more recharge during the wetter months. Any clay lenses that my colleague just discussed might also slow down recharge. And land cover also has an impact. So for the land cover, we would recommend to use low water requirements vegetation in order to retain more water in the soils. And as a conclusion, the soils in the intervention area are have a low permeability, but still recharge will occur since the water table is shallow, as I said. And we confirm that implementing the measures in the upper part of the catchment is a good idea, is a good choice, because in case of heavy precipitation, that will reduce the runoff and the flood risk downstream.
Thank you. As earlier mentioned by my colleagues, we needed geophysics to be able to characterize the field, and so we used some geophysical methods. Please take the microphone. Sorry. So we needed geophysics to be able to characterize the area, and so we selected some geophysical methods after some preliminary field survey. And this was to investigate the soil layers and their thicknesses, the presence of clay layers which may cause artesian conditions, and to investigate if there are structures that influence groundwater flow. So after preliminary investigation, 2 field sites were selected as indicated, field A and field B, and an auger drilling was done to a depth of about 1.5 meter, and it was noticed that the water table is at about 1 meter deep. So electrical resistivity tomography survey was also conducted with 3 profiles in field A and 2 profiles in field B. Their characteristics is indicated in the table with a length from 60 to 120 meters long with electrode spacing of about 2 meters. Ground penetrating radar was also carried out using the Mala equipment of 250 megahertz. The transects were conducted parallel along the field, and data was collected at a working distance. The result from the core drilling shows that there are 3 main soil layers. We have the humus-rich soil layer, the sandy silt with some of it gritty and part of it fine, and a sandy loam layer. And as earlier mentioned, the water table ranges between 95 centimeters to about 125 centimeters. So the soil layers vary in thickness. The humus layer has a thickness between 25 to 40 centimeters. The sandy silt between 10 to 45 centimeters, and the loam layer has a thickness between 45 to 100 centimeters. The result from the electrical resistivity survey indicates it corroborates with the core result. We have the area in green, so in blue shows water is saturated with water. Meanwhile, the area in red is dry, it's less saturated with water. And the water table is at about 100 meters as indicated in the core. The diagram below shows the sensitivity of the model. So it shows that at the top of the model, it is sensitive. Meanwhile, as the depth increases, the sensitivity of the model decreases. This is also shown in profile 2, where the groundwater table is also at about 100 centimeter, and the sensitivity also decreases with depth. This profile is in field B. This field is drier than the first 2, drier than the field A of the first 2 ERT profiles, and it shows a deeper groundwater table, which is at about 1.4 meters, and as you can see, the area is less saturated with water compared to the other field. The GPRO result also corroborates with the ERT result, with the water table shown on the dotted black lines, which is at about 1 meter deep. The blue line shows a transition from one layer to another, and this is possibly a clay lenses. It shows the presence of clay lenses. This is also confirmed in this profile, which is in field A. If we go to the profile in field B, you see that the water table is deeper at about 1.4 meters, and there is no clay lens in this field. Thank you.
Okay, so that was a lot of information, I imagine, for you all. Certainly for the ones that don't have a background in ecology and geology. I myself do not have a background in geology, so. So we will present now our conclusions in a few bullet points, just as a take-home and our final advice that you'll remember. So first, about the water quality and the surface water hydrology. Like I said, there was too much phosphorus, there was too much cobalt and too much zinc. The reed beds can help remove the phosphorus. However, we need more reed beds that are planned at the moment. For the surface water hydrology, at the whole catchment level, they will stabilize the discharge of the river, the Boechout, which is nice. However, locally here, the source area, the plantation of the trees will suck out some water and will reduce the discharge and the recharge in this area specifically. The weirs, so those small dams, they will work as intended. So they will make water percolate more in the soil. However, the area that they are effective is very limited to this source area as well. And then for both our parts, start measuring. So our measurements, our conclusions are based on one measuring point, which is statistically, detrimental, in lack of a better word. So yeah, if you want to improve the quality of the water, you need to know the quality to begin with and the trends in time. Because at the moment, our quality measurements were taken when there's a lot of rain. We don't know if that's the impact or not. The same for the model. The discharges need also to be measured more consistently in time. So that's a big take-home message from our part. Measure the quality and also the discharge more in time to see trends and to help further projects about the surface water. Because next year there will be a new group of students and they will be very happy with more data.
And for the urban infrastructure, our conclusions were that indeed impervious surfaces affect the runoff and the infiltration of the area. And then we would like to recommend the implementation of low-income developments. That's the LIDs, for example, the green roofs, the impermeable pavements, and also the rain gardens.
From the hydrogeology group, the three main hydrostratigraphic units have an influence on groundwater, but as shown for my colleagues, there is no really artesian conditions. There's small clay lenses maybe in the southwest of the area, but as back from the work of the geophysics group, there's no really clay lenses that could let us think about artesian conditions. And also the saturated hydraulic conductivity of the soil is very low. Therefore, the prospect of recharge will also be low. But to wrap up this, also all of these conclusions are made in pedal transfer functions that could be a very good way of rule of thumbs. But if we want to further analyze and to get more close to a real value, we suggest to a proper groundwater model must be addressed, and also a surface groundwater model, coupled model could be a good strategy, since the groundwater table is very shallow, so of course this will have a very close interaction.
Okay, so to conclude, the study area has three main soil layers. We have a humus layer, sandy silt, and the sandy loam. with thicknesses ranging from 10 centimeter to about 1 meter. There's a few clay lenses which might cause aquifer artesian condition, especially in field A. And there seems to be no major structures in this area which might influence groundwater flow as indicated by the GPRO radagram. And it's suggested that to increase water storage and infiltration, organic matter can be added to the soil to improve infiltration and soil water retention. Thank you.
Okay, thank you very much, guys. I'm sure there will be, well, lots of questions. I hope there will be lots of questions. Will that work, Sophie? Well, alternatively, you just come to the front, and depending on who is asking. So, who opens the floor with questions?
Groundwater quality was suffering from a few elements which were exceeding the European norms. Do you have any suggestions to eliminate this pollution of certain elements, or do we just have to face them?
Yeah, so my colleague Joris was more specified in that area, so he will answer your question.
So for the zinc problematic, it's likely caused due to pollution in the nearby industrial site from Boechout, which was previously known as Boechout and Morpent. So as of my knowledge, there were already 2 groundwater projects conducted in 1999 and 2003. Likely these groundwater remediation projects were not enough, but I think for the moment the time is already so far advanced that I think the zinc pollution is already now so widespread that it's very hard to eliminate the whole zinc pollution right now. So what could be done is maybe look at some other nature-based solutions. There are, for example, some plants that are known to capture some of the heavy metals like zinc. So that could be one of the solutions, but probably the zinc pollution is already so far spread that it's very hard to eliminate everything now. I think maybe the projects in the past should have been conducted more better to, well, eliminate the problems now, but that's already too late probably.
Yeah, I want to add to that. So we think it comes from that source. Of course, it can be for anywhere. So first, maybe start also searching if the pollution originates from that area, because maybe it is a new pollution somewhere else. I hope not. But then, if you want to reduce the zinc, it will not be easy, but it can be interesting to look if you can combine it with the reed bed you're planning to install, because those are already plants in water. So if you can, maybe even the reed plants themselves can remove zinc with sedimentation. There exists some things for that. So I think it can be combined with the reed bed. How effective it will be, that's another question. It will never be as effective as a chemical reactor. But of course, we don't want to turn the nature area here in a chemical plant, I imagine.
Also, the concentrations that we found were far above the threshold, so I think it was about 3 times the threshold itself. So the plants could be one of the solutions, but it will, I think, never be enough to reduce the pollution entirely. since the concentrations were really very, very high. So.
Does that answer your question? Does anybody else have questions?
I have plenty of questions, but I'm not going to ask them. But I'm sure Kumbra has.
Is my understanding right that you estimate that the weirs can solve part of the problem and not the reed belts? The weirs. No, I'm not talking about heavy metal pollution anymore, generally spoken.
You mean on the surface runoff? Yeah. The effect of the weirs compared to the reed belts?
Well, actually, we found that the weirs effect is limited. But anyway, there was a suggestion, and we put that in the report also, that we can implement additional weirs downstream at which it can reduce or regulate the water surface runoff. So that was our main concept.
More questions? Was it clear enough?
But we want the written report to study it.
Yeah, of course you will get the final report, that's for sure. And I've insisted that they put in the annexes all the data they've collected, because that will be very, very valuable. From VMM, any question? Not VLM. VLM?
Just, can I summarize this whole thing as we should stop thinking about infiltration and start talking about buffering instead of infiltration?
Yeah, I can speak firstly for the hydrogeological part. As I said, in the end, we only did these pedotransients function that are like a rule of thumb, but the results are like the infiltration capacity is very, very low in the area. So I don't know if the right question is the other thing is good for runoff, but for sure infiltration prospect is low. So I think that at least you should rethink about another kind of solutions. Someone? No?
So from that point of view, the reed belts are also a very good option. The what, sorry? The reed belts. Yeah. It's a question or an affirmation.
Yeah, so the question is, will the reed belts also help infiltration of water in the area? Yeah. I suppose this would be one of the plans.
Well, actually, because we used wet-spas model, we were not able actually to model everything present because it is we suggested that we can use other models such as Hydros 3D in order to model better the interventions. However, concerning the infiltration in the area, it showed, as being seen, it is not very effective, what the interventions showed. But we did not actually delve deep into this part. We delved deeper into the part of regulation of the discharge and recharge in the area. So I don't know if that helps in answering this question. Yeah. Yes. 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 Kind of relation, you mean, between the... actually, we found certain, as we said, mismatch in the measurements between the simulations and the measurements that we found. So that's why we cannot count on that. But we prefer better data quality to be present in order for us to be able to do this.
Okay, I'm breaking my own rules. I will ask a question. I really did not get what your obsession was with this artesian water table, yes or no. So can you explain that? What would have been the relevance of it? But we can bring you to one place in the catchment where even in the summer, water is coming out with pressure. Yeah? In the central part, you haven't been there during the field trip, but it is there. Yeah? So, I mean, we can show it. Yeah? It's so the answer you have is that according to the geological data, it is not obvious that it's there, but we can definitely show you that that at least we have like a permanent spring water coming out. Yeah. I don't agree with your answer, a real model. I mean, if you say we don't have enough data, that's a thing, but it's not a matter of a model, it's maybe a matter of data. So what you're actually saying is the geophysical measurements, they would have been better in drier conditions, and so the results you present, we have to take them with a pinch of salt? Okay, that's, I think, an important point. I hope it's in your report. More questions?
On one slide, I forgot who the speaker was, but on one slide it was said that the new forest reduces runoff, but it increases water consumption. I think that makes sense, but it wasn't clear to me what the net effect was and whether it's a good thing or not.
Wait, let me run, or use that micro. Try it.
Yes. So actually, yes, as we found out, since the forest is mostly deciduous and there are trees present instead of grasslands. Actually, yes, So yes, it consumes water and it limits the presence of water in the area. But at the same, and it captures, as we said, it captures the water. So one of the main recommendations is to actually keep the forest, but make it less dense, add more biodiverse, by which more biodiversity, recreational processes can be present, and we can also limit the consumption of water, as we said. Yes.
Be a solution to bring more natural water to the area, because now the rainwater is not always going straight to the ground. It's, in many cases in Boechout it is still going to the riolen, as you know, together. Would this help the water infiltration in the area?
All right, is it okay now? Okay. The planting of trees in the area will actually increase infiltration, because if you look at the top surface, we already have a hard part at the top surface, which limit the infiltration of water into the soil. By planting trees now, they'll break the hard part, creating more pores into the soil for infiltration. And coupled to that, the trees will increase, why you consume more water is that trees will increase transpiration. we increase the level of transpiration in the area. So actually, during summer periods, more water will be extracted from the area as summer because more transpiration will take place in that area from the trees. So if we can, like Shirley said, we can look at more biodiverse area, like plant more species, different species of trees, integrate the project in such a way now we can have a soil, the topsoil covered with shrubs and grass, and then you have a layer of trees, then it will make it more diverse in such a way, will reduce the amount of transpiration also, and also infiltration will also increase in the area. Thank you.
In summary, trees, they consume a lot of water. That's something often forgotten. So indeed, if you plant trees, it may improve the infiltration of the water, but trees, we all know that in summer trees are beneficial because they bring a lot of cooling when it's hot. Yeah, but why do they cool? That's because they are evaporating a lot of water. Yeah, so the tree, as for cooling, it only also works when there is enough water in the soil so that they can evaporate it. So we like the trees to cool it down, but they need the water. Of course, in the winter, they are deciduous trees, so that they don't have leaves. So in the winter, they don't evaporate anything. So in that period, it will be beneficial to get water to infiltrate. Of course, once your soil is saturated anyway, it has nothing to infiltrate anymore. So that's a bit the balance. The question about the drainage, the riolering, what do you call it again? The sewage system, etc. It's something I would have liked the urban hydrologists to look into more detail, but that didn't really get to that. So I think the next year students can maybe study that in more detail. There's some groundwork has been done, but there is room for doing more work.
Yeah, I have a question for the commune. Yeah, so we talked about the nutrients a lot, and that there are a lot of nutrients. But we also know there's a lot of greenhouses in this area. Is there a possibility from them to get data from, I don't know what the wastewater is, for example, because I assume they use a lot of water. Where does that water go? Does it go into the sewage? Is it treated, reused? I know it's difficult for those enterprises to share those data, but I think that will be very important for next year's students because that can be a potential large source of nitrogen and phosphorus. Because, like we said, the reed beds will help, but it's like a remedy. It's good to help the symptoms, but it's not the source of the problem. You need to also reduce the nutrient levels that go in the Boechout. So it's maybe also some area. Maybe here the people in the commune know the right people. We don't. But if you can get the data, they will not be happy to share it, I think. But
maybe I can answer a little bit. But the greenhouses, they use the water from the rain, falls on the roofs, and they have a big bassin where all the water comes into, and they use water from the soil, 10%, I think, something like that. But they reuse all the water. Everything that comes in the air, it's with, yeah, I can't. Yeah, it's all used again. It's with little, ja, ik zal het even in het Nederlands zeggen. Eigenlijk wordt het water dat verdampt, er wordt water gebruikt, dat is eigenlijk allemaal op van die vezel... Het is substraat eigenlijk waar vooral de planten in groeien. Daar zijn allemaal collectorsbuizen waar het water dan doorvloeit eigenlijk. Hetgeen dat er te veel is, dat loopt dan ergens anders weer in, dat wordt terug opgevangen. Hetgeen dat verdampt wordt, zijn allemaal kleine gootjes die dat eigenlijk allemaal terug opvangen en dat wordt allemaal terug hergebruikt. Dus eigenlijk al het regenwater dat ze gebruiken, wordt ook gebruikt en terug opgevangen als dat verdampt.
So technically there should be no discharge of the water to the
No.
environment.
No.
And they also used mest, fertilizers, I suppose. So the use of fertilizers, will it not accumulate then if they always reuse it? I mean...
Yeah, I don't know. I don't know.
There is water going into the sewage.
There's also a basic water treatment system. The big greenhouses have a basic water treatment system.
And afterwards? So,
filtration.
Okay,
Yeah.
so they use the water, they treat it with the basic water treatment.
Mostly they use the reverse osmosis technique in the limited installation.
Reverse osmosis?
Yes, in the limited installation.
That's fancy.
Yeah.
Okay. And then they discharge it into the area. Yeah. Okay. Okay. Sounds very interesting for next year students, I think.
Okay. Any more questions? Do you have any questions?
No, that's very interesting.
Peace. The study says that there is a less or little infiltration in the ground due to the lame ground, the clay and so on, and otherwise there is a forest, but due to the high summers we may expect in the coming years, will there be water enough to keep the forest in that area healthy, or do we have to bring more water to the area? Coming back to my first question.
I think that's a good question that could be answered with a simulation. Yeah, because to know really, to address the amount of water that would be consumed, how the climate would change, and if more water is needed or not. I think that the results that we have now, maybe there's another question. It's not easy to answer, but that would be a very good question to ask to next year's student, like future simulations also, because I think that it's not only only seeing the past and now, and at least in our part, at least a little bit of the future, how the impact of climate would be in the area, and how a nature-based solution be sustainable in time, as you were asking, because it's a good question. If you bring more forests and in 20 years you don't have enough water, you will have to bring more water to keep it running.
But with the fine soil texture and the shallow groundwater table, I think there will be significant amounts of capillary rise, no? So that should provide enough water for the trees, I think, in the future. Because if there's no water here, then I'm worried about the rest of Flanders. Because here is a lot of water, and the soil texture is very dense, so it can hold it very well. So by the time that you get droughts here, that the trees die, yeah, I think Brussels is already dead.
I agree with you. I may add on that colleagues from forestry in the University of Leuven, they are looking at this aspect of competition of trees in Leendal forest, and they're doing experiments and to thin out, to reduce the competition between the trees. But now your trees are still only babies, so encourage them to grow, and maybe in 30 years, if need be, then people will come after us, can thin them.
They'll call them.
Let the trees grow for now.
I have maybe a question. I think the only thing you said that would significantly bring water into the system is more precipitation with the p-value. But okay, there should not be that much change in precipitation with climate change, but the distribution will be different. So what is like a possible measure you would take to like to keep that water also in the winter to be able to percolate into the groundwater table. Because there's two weirs, but yeah, do you have any more measures you could teach us? Is it a clear question?
Hello? Okay. So yeah, there are two weirs at the moment, and they will help in this limited source area. One thing we failed to mention is that the reed beds will also slow down the flow speed of the water, which gives it more infiltration potential. So everything that slows down water, maybe also downstream, let Boechout meer kronkelen back, and that it takes more back its natural shape, will also help. If anyone else wants to add to that, I'm only specified for the reed beds. But yeah, everything that slows down water will help. That's the main takeaway, I think, for that.
Yeah, sure. And the reed beds have quite a lot of surface area, so in that particular area of the reed beds there will be sure more infiltration. And so when heavy rain events will occur, I think those reed beds will positively influence infiltration into the groundwater table. Also for future events of climate scenarios.
And of course, ontharden. Because in the future there will be more extreme precipitation events. That's basically the whole problem. And in Flanders we're really good at making concrete everywhere. So that's a big part, we see it more in modern infrastructure, which is very nice. But to have, for example, pavements where infiltration is possible, things like that can also buffer a lot water if applied to large surface areas. But yeah, at the moment we don't have a view of all the measures together, which may be interesting for the future. And giving the future students a lot of work.
Sorry for that now.
Okay, thank you.
Margaret, do you have anything you want to add? Okay, I think we had some interesting views, something to think of. Thank you very much, everybody.
Is goed, hè? Ik heb het wel niet allemaal heel goed verstaan. Soms voor mij ja, veel, ja, mijn Engels is al al lang geleden dat ik lang geleden dat ik nog Engels heb gesproken, dus het is wel geswitcht al maar het is veel vakjargon. Dus ik heb een aantal dingen gemist.
Echt een paar gewonnen van kijk, dit zijn jullie klanten, wat heb je begrijpbaar.
Ja, maar
ze krijgen van die ook altijd zo moeilijke woorden dat ze willen begrijpen.
Ja, dat is zo, maar dat is in mijn professoren ook zo. Ik denk dat dat wel makkelijk is, maar dan moeten de mensen zo ook kijken. Ja, zeker. Maar het is niet voor mij dat ik zo onmiddellijk zo echt vragen kan stellen, omdat ik denk van ja, ik heb misschien dingen gemist. En ik stel dan een vraag en dan kan ik zo juist 5 minuten over discussiëren. Dus maar het is wel knap, hè? Het is wel knap, hè? Ja.
Dus van die urbane ecologie, dat is van de hoofdstad, die de oppervlaktewater hebben gedaan, dat was een eigen initiatief van die metalen te analyseren.
Ja.
Ik weet niet of ze zelf de link hebben om op de overwebsite te gaan kijken, maar wat er allemaal ingeboden is.
Op een website staat de gebieden staan eigenlijk wat er geschreven is geweest of wat er onderzoek is geweest, maar staat er
Nee, dat moet echt al het is wel zo lang niet waar dat ze er wel in misschien wel in kunnen zetten. Ik stel voor pas met maar ik heb een zuidconcentratie die heel diep zit. Dat is zo wel.
Dat is toch niet.
Maar ja, de zuidconcentratie die gaat meer richting, ja, wat is dat, Oostbeek? Die gaat meer richting Brugge. Maar ja, dat is een andere grondwatertafel, dat heb ik ook niet. Ja, ze hebben heel diep gemeten, hè. Maar in Zuid-Brugge is heel diep, hè.
Zelf ben ik zelf niet zo bewust, omdat dat zit in alles. Dat zit in je koopt, dat zit in je standaard, dat zit in de lucht. Als er boeren komen van de land, uiteraard. En zo zijn er ook meer in. Maar dan moet ook koopbouw, dat vind ik. Zink is aan de kant van het land en hij is niet iets te werken. Koopbouw, dat is echt niet.
En wat was het dan?
Maar dat heeft niet te maken met historische landbouwactiviteiten of ik weet niet, leerlooierijen of zo.
En het is wel in de collaboratie.
Maar ik twijfel niet aan de resultaten. Volgend jaar nog eens terugkomen zeker?
Ja.
Ik ga het register bekijken bij ons van dat er een fijne onder rond is zitten. Dat er ingepakt is. Oké.
Ik zou meer plezier komen. Ik spreek van een groot op. Hebben zij een ding?
Ze zijn belangrijk. Ik zie die ineens aan de
Thank you.
Hier was natuurlijk het metaal bekend, dat ze verzinkerijen deden. Hè? Maar hoe ver kan dat eigenlijk transport gebeuren als we daar wat wat die baan kan dat transport dat was sneller nodig ja, genoeg had hier en als je het grond aan als je niet zelf natuurlijk recht
maar ja, dat is een veronderstelling.
Maar kan niet zo dat kan van alles zijn, dat is niet zo
zij zeggen, dit is een veronderstelling. Maar misschien zijn er nog andere oorzaken.
Ja, dat is waar.
Dan moeten we zien waar we toe.
Maar wie gaat dat weten?
Dat kan van overal komen natuurlijk. Ik heb het zelf niet wel.
Stefan, ja, Stefan, dat is ook.
Dat is mijn collega.
Hallo. Hallo. Er is ook een, dat is ook van verleden geweest, hè? Maar dat voor het recyclageparcours is, dat was vroeger met de domein, hè? Nee, maar dat is lang voor mijn tijd. Ja.
Bomen zeggen. Water nemen.